Alright, so there's different ways that you can solve systems. Like I said, yesterday we did it through graphing in the table. Today we're going to do it algebraically. So we have elimination and substitution. I would say get good at one and then use that. Okay, pick one you're good at, go with that. So starting out, like I said, this is elimination. I got 12x minus y equals 14. Negative 2x minus 5y equals 8. And since we're doing elimination, I need to eliminate one of the variables. Either got to eliminate the x or got to eliminate the y. What I look for, if I'm going to use elimination to solve the system, is I look at the signs in front of the variables. I try to find opposite signs. So this one's positive, this one's negative, this one's negative, this one's negative. So my x's have opposite signs. So I'm going to try to eliminate the x's because that's probably the easiest thing to do and I don't have to do as much math with it. So what I want to do is I want to turn 2 into 12. So what do I multiply 2 by to turn it into 12? 6. Okay. So everything on the bottom is going to get multiplied by 6. So I got 12x minus y equals 14. So 6 times negative 2, I got negative 12x minus 30y equals 48. Okay? So 12x minus 12x goes to 0. So I've just canceled out my x's. Y minus 30y, I have negative 31y. And add those up, you get 62. Divide to get y by itself. Y equals negative 2. You then need to plug that negative 2 back into one of your equations, into one of the original ones. I'm not going to plug it into one of these. Okay? Pick one up at the top. I can plug it into the top one or the bottom one. Pick one. Okay. So this negative 2 is going to go into the top equation up here for the y. So I plug that in, and I got 12x minus negative 2 equals 14. So 12x equals 12, x equals 1. I need to check it in case I screwed up somewhere with the math. So we're going to plug those values in to one of those. I guess I'll just go ahead. I'll plug them into the top. So I got 12 times 1 minus negative 2 equals 14. So I have 12 plus 2 equals 14. Is that true? Does that work? Yeah. So you then know that your solution, well, is x, y. Yeah, it's not what I meant to write. Is 1, negative 2. So, from what we did yesterday, what's going on at 1, negative 2 on a graph? What's happening there? They're intersecting. Right, they're intersecting. What type of system is that? We named them, remember, consistent, inconsistent. What type is this? Consistent? Consistent, independent. Yeah, good. Inconsistent is parallel. Okay? Consistent, independent. Go ahead now and we'll do number 3. So I got 9x plus 8y equals negative 28. Negative x minus 2y equals 12. Like I said earlier, I check for opposite signs first. In this case, the x has opposite signs and the y has opposite signs. So we can really eliminate either one. Which one do you want to get rid of? The y's? Okay. So what am I going to multiply the bottom by? By 4. So 9x plus 8y equals negative 28. Negative 4x minus 8y equals 48. Okay, so we've eliminated our y's. 9 minus 4, you get 5. So I got 5x equals 20. X equals 4. Plug it back in. Which one do you want to plug it into? Bottom. Okay. So this value is going in for that x. So I have negative 4 minus 2y equals 12. Negative 2y equals 16. Y equals negative 8. So just like before, we need to plug it in and check. And I'll put it in the bottom one again. That seems to be the easy one. So negative 4 minus 2 times negative 8 equals 12. Negative 4 plus 16 equals 12. That's right. So our solution then is 4, negative 8. So again, we would have an intersection at 4, negative 8. You have a consistent, independent system. If I put it in the calculator and looked at the table, what would the table look like? What would be happening in y1 and y2? Well, yeah, on the graph. What's going on the table? They'd look the same. Right. The y1 and y2, it would say negative 8 when x is 4. Questions on those? No, don't knock my Christmas lights down. Alright, 5. 5y plus 4x equals negative 26. Negative 4y equals negative 20 minus 7x. Okay. I have to do something before I start eliminating variables. We need to rearrange this, and you can put it in standard form, meaning x then y. Or just make sure you have all your y's on top of each other and your x's on top of each other. Plus 7? Alright, so we're plus 7. So 5y plus 4x equals negative 26. Negative 4y plus 7x equals negative 20. Okay? What are we going to eliminate? The y's. How am I going to eliminate them? Yep. Multiply the top by 4 and the bottom by 5. So doing that, I have 20y plus 16x equals, thank you, negative 104. Negative 20y plus 35x equals negative 100. Okay, we've now eliminated our y values, which is what we wanted to happen. 16 and 35 is 51, so I have 51x equals negative 204. So x equals negative 4. We're going to plug it back in. We're going to plug it into one of these here. Okay, plug it into one of those there. Top or bottom? Okay. So this value is going in for that x. So 5y plus 4 times negative 4 equals negative 26. 5y plus 16 equals negative 26. Oh, that should be minus 16. Minus 16. 5y equals negative 10. Y equals negative 2. Plug it in, check it. It works, because I've already done this 2 other times. So your solution is negative 4, negative 2.